Now let's take a look at acceleration. So it's very similar to how velocity was defined. Acceleration, A, is a vector quantity, and it is defined to be how the velocity changes with time. So the rate at which our velocity changes. And since velocity was a vector, a change in velocity is a vector, and therefore acceleration is a vector as well. The units of acceleration, well, we have here the units of velocity are in meters per second, and the units of time are in seconds. And so we have here the units of acceleration are meters per second, meters per second, or we say this is the same thing as meters per second squared. So acceleration is in meters per second squared, and it is the rate at which velocity changes. Again, just like velocity, whether or not our acceleration is positive or negative depends on our coordinate system. So if I have the velocity changing in the negative direction, I would have a negative sign there. Let's take a look at some examples, and let's see what we mean by speeding up and slowing down. Actually, let me define these first. So speeding up, remember, speed is not a vector, right? So speeding up, what this suggests is that means that our speed is increasing, and therefore our acceleration must be in the same direction as our velocity. Okay, so this means that if I have a velocity which was to the right, I also have a change in velocity which is to the right. Or since the change in velocity is our acceleration, we have an acceleration to the right. So speeding up means we have the speed is increasing, and therefore the acceleration is the same direction as the velocity. Slowing down would suggest that we have our change in velocity would be opposite of our velocity, or anti-parallel, right? So we have, say we had a velocity to the right. If we have an acceleration to the left, it means we are slowing down. So let's take a look at some examples here. We have a coordinate system defined over here, the positive y being upwards, positive x to the right, although this is all one-dimensional motion, just going the x direction. And we see here in A, we have a velocity was originally off to the right, which is a positive v, right? This is off to the right. Now our acceleration, which is a change in velocity, is also off to the right. And so if we have an acceleration the same direction as the velocity, then it would speed up. So in A, we would say that it is speeding up. In B, we have a velocity still to the right, but our acceleration is to the left. Therefore, our change in velocity is opposite of our initial velocity. And so we would say in this case it is slowing down. So maybe in case A, he's hitting the gas. In case B, he's hitting the brakes there. Okay, so this would be slowing down in case B. In case C, we see that we had a velocity which is actually negative. We had a negative velocity, yet we had a positive acceleration. Acceleration was to the right, which we have defined to be positive, and velocity was to the left, which we defined to be negative. So because these are opposite of each other, it is slowing down. Okay, so in case C, the car is slowing down because the acceleration is anti-parallel to the velocity. In case D, however, we have a velocity to the left, a negative velocity, and we also have an acceleration to the left, so a negative acceleration. These two together cause the car to speed up. It's speeding up in the negative direction, but nonetheless it is speeding up. Okay, so its velocity is becoming more negative, which is what we would say is speeding up. Another example here, in this one they didn't actually, the figure didn't have a coordinate system supplied with it, but we can actually just look at our units here. Velocity v naught is 70 meters per second, and acceleration is negative 1.5 meters per second squared, meters per second per second. So we can say here that it's obviously slowing down, right? And actually, sorry, we can figure out our coordinate system based off of the values here. Clearly, a positive x is to the right, and we'll just assume a positive y is upwards here. Okay, so it started out with an initial velocity of 70 meters per second and an acceleration of negative 1.5 meters per second squared. So initial velocity to the right, yet a change in this velocity, which is to the left. So what this means is it's going to slow down. It doesn't mean it's going to travel off to the left, not quite yet, but it's going to slow down. So this was all at time naught equal to 0. And then at some time later on, 40 seconds later on, we can see that our velocity has decreased now to 10 meters per second. It's still accelerating. It still has the same acceleration of 1.5 meters per second each second to the left. So eventually it is going to come to a stop. And if it does continue to accelerate to the left, its velocity will eventually go to the left, but that hasn't quite happened yet. So we just see here that it started out going 70 meters per second. 40 seconds later, it's only going 10 meters per second, so it's slowing down, coming to a landing or something. A couple things here to note about acceleration. Acceleration is a change in velocity with time, and there are a few different ways in which velocity can change. We talked about speeding up and slowing down, but remember that a velocity is not only a magnitude, but it's also a direction. So ways in which velocity can change is that it can speed up, it can slow down, or it can also turn. Okay, so an object which is doing any of these things, speeding up, slowing down, or turning, is accelerating. Okay, so there are 3 ways in which we can accelerate: speed up, slow down, or change directions. Right? So we could say later on, later chapters, we'll talk about things going around in a circle at a constant speed. So let's say we have something going around in a circle at a constant speed. So it's traveling in this path, and it's going in this path at a constant speed. Although the speed is constant, it is still accelerating because its velocity is changing. The velocity, remember, if I take some instantaneous velocity, the average velocity between these 2 points here, it goes off in this direction. So that was its velocity here. And then take 2 other points close together. This is their velocity there. Oh, this should have been a straight line. I apologize. So this would have been the velocity there. Clearly, these velocities are different. They have different directions. Therefore, they're a different velocity, and the particle is still accelerating. So just because we have constant speed does not mean we have constant velocity. So an object can still accelerate even if the speed doesn't change. However, if we say that we have constant velocity, what this means is that our change in velocity is equal to 0. So a change in velocity would be 0 anytime we have a constant velocity. And so then if we have a constant velocity, what happens to our acceleration? Our acceleration is going to be 0 divided by some time, and we would have 0 acceleration. So if we have constant velocity, we have 0 acceleration, but not necessarily true if we have constant speed. We need to be sure the direction is not changing as well. So so there's acceleration. Also sometimes it's referred to if an object is slowing down, sometimes we call that deceleration. It's speeding up, sometimes referred to acceleration, but they're still both accelerations. We could just say accelerating in the positive direction or accelerating in the negative direction.